Hi, everyone. I'm Ryuji Wakikawa from SoftBank. I'm very honored to be here as a keynote speaker, and I'm going to present SoftBank Network Vision towards 6G. I couldn't attend this conference real time, so this is a recording. And during this conference happening, I actually be in the United States for the other meetings, and due to this COVID situations, I didn't visit. I didn't travel the last 2 years, and I'm leading the advanced technology divisions, and I need for all the innovations and the technologies. It's all about the people. So I need to be go visit and finding the right technology and the innovations. And I'm so sorry this is a recording, but I'm gonna share how the SoftBank see the beyond 5G and 6G. So again, I'm Ryuji Wakikawa. I'm the Vice President, Head of the Advanced Technology Divisions. I'm responsible for the new technology and the new business in the SoftBank. I also Board Director of the HAPS Mobile and the Executive Board of the HAPS Alliance, which we are currently heavily working on the development of the Stratosphere platform. I'm going to cover that in my talk. And about the 6G, we expect a 6G is coming around 2030. As you probably know, 5G has just begun last year. So we are currently developing the 5G infrastructure all over Japan. And the 5G itself also evolve next few years and next decade. But these generation migration from 1G, 2G, 3G, it's about every 10 years, these evolution happening. And this is the kind of a history of the mobile communication from 1G to 5G to 6G. Until LTE, a lot of access technology, FDMA, TDMA, CDMA, OFDMA, a lot of technology evolutions. And 5G inherits the same access technology from LTE. Biggest difference is frequency. 5G, we adapt the millimeters wave, which is a 28 gigahertz spectrum in Japan. And the 6G is about the telehealth, frequency expansion beyond the millimeters. That's how the 6G is discussed right now. But before going to detailed technology, let me explain the concept of the 6G. This is today's network. Our mobile network consists of thousands of base stations all over Japan, and serving all the phone, including a smartphone, PC, tablet, and fixed phone. It's all about consumer services. 6G in 2030, here a base station. Of course, there are a bunch of base stations still, but there will be a HAPS, which is a base station from the stratosphere, and satellite connectivity from space. And also edge computing in the middle, because they're building pictures. These are data center. Until 4G, 5G, it's about connectivity. But I think that from 5G and beyond, it's network and the server. So our infrastructure can offer the server capability as well as the network. And this infrastructure is going to be providing services to the industry, enterprise, and the consumer services, and even us and society, which is educations or monitoring for the net zero emissions. So this infrastructure is going to be very fundamental infrastructure for our society. So this infrastructure we will be developing next decade. SoftBank has defined 12 challenges for 6G. I'm not going to detail every 12 challenges here. We actually published the press release the other day. If you can Google 12 challenge for 6G SoftBank, you can find the articles. So please refer that. Today's my presentations, I especially focus on the HAPS and telehealth communication. These are two major topics we are very focusing on. So the first is area expansions. So far, the mobile network is providing for the smartphone, which is the people are carrying. Our infrastructure is only available where the people live. So if you see the circle on the bottoms, the middle center is where the people are living. So this is where we provide a connectivity. But from now on, only it's a smartphone, but also devices, vehicles, like autonomous vehicle, and many IoT devices, sensor will be distributed and deployed all over the world. So our connectivity has to be ready everywhere. So we have to expand our area to the isolated islands, mountains area where the people are not living, and also like airspace. There are like a lot of like new technology coming for the drones and the air taxi and so on. And we probably need to provide a connectivity to these devices as well. The existing mobile infrastructure is especially like providing the coverage to the surface of the ground. But now we have to provide connectivity to the space and everywhere. What type of coverage? So far, it's the left side. We are providing the area where the people are living. This is a population coverage. SoftBank achieved more than 99.6 or 7% already against the population coverage. But however, to the land coverage, still 60 to 70%. Rest of like uncovered area, 30% is all about the mountains. Japan has a lot of mountains in the land. So we didn't like provide a coverage because no one there. But our mission is going to be providing the coverage to the uncovered area today. How? Is a HAPS. In order to provide mountains, islands, the biggest challenge is the fiber, for example. There's no fiber, there's no power. So building all the tower to these rural is very, very costly. We probably need another $1 billion to provide 100% uncoverage in Japan, which is a very challenging. So we are developing the new weapons, which is a HAPS. This is a base station from the sky. First, I'm gonna share just one video about the concept.
Throughout history, we have ventured into new territories. We have reached and explored outer space, but not the stratosphere. In 2017, SoftBank established HAPS Mobile and set off on a journey to the stratosphere. For what purpose? For the internet. With the widespread expansion of mobile devices, we now use the internet whenever and wherever we like. But half of the world still does not have access to the internet. So for the future, HAPS Mobile will take up the challenge of building a stratospheric telecommunication platform system, HAPS. HAPS is an unmanned aircraft system equipped with a mobile base station. It uses solar power to fly in the stratosphere. With this aircraft transmitting radio waves from 20 kilometers up in the sky, it can cover an area with a diameter of 200 kilometers. This coverage is equivalent to about 400 base station towers on land. HAPS's big advantage is that people can use the mobile devices that they normally use. Along with smartphones, HAPS can even be used for low-priced and energy-efficient IoT chipsets. Unlike satellite communications that require dedicated equipment, existing 5G and LTE can be used as is. With today's communication infrastructure, there is no internet where there are no people. But there are IoT devices, observation sensors, and cameras that are waiting to be connected. Imagine this: a future with HAPS aircraft flying above us, covering wide areas, resistant to disasters. The internet is a core infrastructure, just like water, gas, and electricity. We're on a mission to make the technology accessible for everyone. We will continue to take on the challenge of developing the future of mobile communications to deliver internet connectivity across the entire world.
So this HAPS Mobile is a subsidiary of the SoftBank. And when we have developed this platform, this project was a highly confidential one. So, but anyway, this activity is led by SoftBank now in Japan. And the SoftBank has multiple solutions for the internet from the sky. One is the HAPS, which I'm going to detail more later, but it's about 20 kilometers from the ground, but also low Earth orbit satellite, LEO satellite. You're probably familiar with Elon Musk's SpaceX. They are offering connectivity from the LEO satellite. But there's another company named OneWeb. SoftBank has invested. And the OneWeb also launched hundreds of the satellite already, and we probably start the commercial service soon. And there is another satellite company called the Skylo. Skylo uses a geo satellite, so stationary Earth orbit satellite, which is 36,000 far away. But the Skylo providing the connectivity to the IoT devices from the geo satellite. So SoftBank has a lot of portfolio for the solutions internet from the sky. However, every solution is a complementary one. It's not like competing each other. So depending on the use case, we use the best available commercial services for the customer. And what is the difference between satellite and HAPS? Is about the latency and the spectrum. The satellite use dedicated satellite spectrum, which like our phone cannot receive. However, HAPS is just like 20 kilometers from the ground, and we plan to transmit the regular ISM spectrum, which your iPhone, your Android device can receive. So your smartphone can communicate with the base stations on the HAPS platform from stratosphere without any changes, which is a strength of the HAPS. And the latency is much, much smaller, like 0.3 millisecond one way. So we can potentially equip the 5G base stations or maybe 6G base station in the future in the HAPS. While like a satellite, there, the coverage is stable, but the latency is a little bit longer. So 5G performance may not be achieved over the satellite. Anyway, there are like pros and cons. And another thing is deployment. HAPS is a regular airplane. So we can launch the airplane to the hotspot or dedicated locations and then provide a connectivity on a particular spot. While like a satellite, LEO satellite, they need a constellations. So about 500 to 600 satellite will be launched. And this satellite is moving around the orbit to provide an entire Earth coverage, like a few hundred small satellites are required. And this satellite has to be renewed every 7 to 10 years because of the battery die. Basic efficiency is also different in terms of CapEx wise and deployment wise. And this is going to be mixed. But the LEO satellite is available today, while HAPS we are still developing. So the timing of the service availability is also different. So I'm going to give you more detail of the HAPS technology. First, we will share about our airplane.
HAPS Mobile uses an aircraft equipped with a mobile base station that is designed to fly for several months. Using lightweight carbon materials, it can fly even with little wind. With a total wingspan of about 78 meters, it can also withstand turbulence. The wings house solar panels, while the aircraft is equipped with high-performance batteries. During the day, the aircraft flies, while solar panels charge the batteries. During the night, the aircraft continues to fly off the charged batteries. The aircraft does not use any fossil fuels, making it completely sustainable. Given these technologies, we predicted the aircraft could fly for 24 hours, and that is why we started the HAPS business. The onboard computer automatically controls the aircraft according to wind patterns. The simple wing-based design improves aerodynamic performance and also makes mass production possible. During takeoff, the aircraft follows guidance from the Airport Takeoff and Landing Center. It flies in circles to increase its altitude. When it reaches the stratosphere, a globally managed operations system directs the aircraft to a specific service location. Once it arrives at its service location, the aircraft flies continuously on autopilot for several months, delivering internet connectivity to the ground. The aircraft's design makes it possible to switch or replace systems as necessary. This makes it compatible with LTE, 5G, and all other types of base stations. The aircraft can also house sensors and cameras. In 2019, 2 years after we started the design process, the aircraft cleared NASA's safety review tests and succeeded in its first flight. The aircraft will soon be flying in different parts of the world. A connected world is right around the corner.
So we have started this project in 2017, and we start the designing of the unmanned aircraft for our base stations. And we prototype 2 airplanes and start the test flight 2019 with the NASA's support. And the 2020, we finally bring this airplane in the stratosphere successfully. So in 2020, even like during the COVID situations, we test flight successfully, like bring into the stratosphere. There was flight time more than 5 hours, and the max wind speed is 58 knots. Lowest temperature is minus 73 degrees. So it's very successful flight. I have some video for flight test. This is a huge airplane, like a 78 meters wingspan. And this is a video from GoPro on the airplane. Yeah, so this airplane can go over by itself and land by itself as well, like regular airplane. And it's going to be a very autonomous pilot. And in this prototype, we equipped LTE base stations and we test radio networks as well. The left upper is ground gate, which is a backhaul of this LTE base stations. In the middle, they test the handset, receiving the signal from the stratosphere and checking how it works. And in the bottoms, we have actually did the video call test through the LTE base station in the HAPS. And in this event, we invite Vinsar from Google and Jim Lai from Keio. These two gentlemen, legend of the internet. They actually started the internet from 80s. We celebrate this moment with the two legends, which is a very special experience for the HAPS Mobile and SoftBank. And this is a mobile network. We plan to build, design, develop these solutions as a part of infrastructure. We have a lot of discussions regarding spectrum in ITU because there's no past experience transmitting the spectrum from the stratosphere. We need to change the regulations. There's a WRC meeting, which is a part of ITU, held in every 4 years, which we can discuss spectrum coordinations and regulations. So the last one was WRC 19, and we successfully got the approval for the 3 new frequency for the feed and link, which is the backhaul of the base station in stratosphere. Regarding service link, which the base station transmit the radio to your handset or smartphone, we got the approval to discuss this agenda towards the WRC 23. So there were some suggestions in the left bottoms, like a service length, 702.6 gigahertz. These spectrum can be used from stratosphere. That's our proposal. The agenda was approved, which is good because the next 4 years we have discussed this agenda and seeking the final approval in WRC 23. After having the approval, beyond the 2023, any operator can potentially use these ISM spectrum from the stratosphere. This is very, very important to make these solutions visible and practical in the future. SoftBank has been working heavily on this ITU meeting and negotiate with every country and relevant entity right now. So let's switch the gear to the frequency side. So I'm going to touch on the spectrum for the 6G. Until 4G, we have a lot of low band, mid band, but the spectrum bandwidth is very small, like 20 megahertz, which is a small chunk of the spectrum. And we have a lot of different spectrum, like 700, 900, 1.7, 2.1, 2.5, but the spectrum bandwidth is so small. 5G has totally different approach. So for example, sub-6, 3.9 gigahertz, 3.8, 3.9, we have 100 megahertz bandwidth. For the millimeters wave, it has 400 megahertz, which is very, very wider spectrum. And 6G is going to be gigahertz bandwidth. So it has a totally different spectrum we will deal with. And where is these gigahertz like bandwidth available? It's a terahertz beyond the millimeters wave, about like 100 to 10 terahertz. That's a terahertz spectrum. There's a lot of spectrum available. So 6G is a green one, and the terahertz band we plan to use for the mobile communications. So this is some spectrum view, and terahertz is next to the millimeters wave. But the interesting thing is beyond the terahertz, that's going to be actually optical. It's no more radio. So for example, in the Japanese radio law, government defined until 3 terahertz as a radio. Beyond that, that's optical. So operators expanding the spectrum for the mobile communication over the years, and now like it's a dead end. After that, we successfully adapt this terahertz for the mobile communications, there's no more spectrum. So this is kind of like very interesting. But this is one of the missions we are working. So combination of the terahertz, and also like there are a lot of research ongoing for the optical communications, which is another challenge we are facing. But terahertz spectrum is like a beam. It's not like a radio, it's like very beam, and may not be transmitted farther away. And there'll be a lot of challenge we are aware of to use these spectrum for the communications. However, there are a lot of like technology development is happening, and also regulatory start looking at this terahertz. ITU WRC 19's the meeting frequency of 137 gigahertz bandwidth was defined for the fixed communication or mobile communications. So this spectrum coordination is progressing, which is very, very important for the industry. So we expect more accelerations use of the terahertz in 6G. SoftBank has started this telehealth R&D from 2017. Originally, there was a big like equipment and just like transmit the radio. And we are adding the network capability and developing the smaller antenna. And also we look at how we can use this telehealth for the mobile communication, because this spectrum is like a beam. It's very, very difficult to track the moving object, but how we can do this? That kind of like R&D we are conducting. What is the use case? That's a very good question. Telehealth bring the new communications. So telehealth communication may not be like today's base station and the smartphone connectivity, but more like data center, maybe replacement of the optic fiber, because radio bandwidth is huge. Telehealth communication can potentially achieve gigabps speed easily. So it may replace fiber cable to the radio. And the near field communication like NFC, because it's radar, by touching to object, they can transmit hundreds of gigabps speed and exchange the data massively. That might be another use case. And the interesting thing is telehealth can also offer in the sensing. Telehealth is like a beam. It can sense an object in the room, for example. So by adding the mobile base stations, one base station can offer in the connectivity as well as the sensing where the people, how many people or some other object. And also scanning is another use case of the telehealth, which is today's use case of the telehealth is about the scanning and sensing. So we can continue to provide a hybrid capability from the telehealth base station. One is a network, another is the sensing. So this is going to be a very interesting use case for the future. So this is all about like our beyond 5G and 6G concept. And I particularly focus on HAPS and the telehealth for today's talk, but there will be more coming. And the 5G is also like even evolving for next few years and next 10 years. So our infrastructure in 2030 is going to be totally different network than today. So we will continue working harder on this journey. Thank you.